Hey everybody, today we'll be talking about 3.1, the complex numbers. You should have received a note outline in your email, so it'll be just like a normal class. I'll talk about the topics on here, kind of clarify some key things, and then go over some examples. And just like in normal class, you should probably stop the video and try a couple of problems on your own. Again, if I sit here and do them all, I'm not going to learn anything new, but you trying them on your own will always be better than me showing you. So with that said, let's go ahead and jump into it. And I'm going to start by talking about the complex number system and imaginary numbers. So what we've done in class is kind of solve for x-intercepts in the past, but I wanted to consider the case if you had something, a parabola like this. Does this have any x-intercepts is the question. As you can see, it does not intersect the x-axis at any point. Therefore, it has no real solutions. Real number solutions, we mean. And by real numbers, we mean the numbers that we know, -1, +1, 1.5, pi, 2.71. These are all real number solutions. So this has none. So what happens if in the next section, what we'll do is we're going to end up factoring things like this and finding solutions, and we're going to run into situations where we end up with imaginary numbers. But let's talk about imaginary numbers. So I, as in your notes, is denoted as the square root of -1. So therefore, what happens if I square I? Well, let's think about this. What's the square root of -1 squared? Well, what's going to happen to the square and the square root? That's right, they're going to cancel. So you end up with I squared equals -1. So these two are going to be important notes for what we're going to do next. So let's go through a few of these examples. I'm going to write a couple of them up, but the first one is the square root of -7. So the square root of -7, I could actually factor as the square root of 7 times the square root of -1. Because the square root of 7 times the square root of -1 is just the square root of -7. So then furthermore, what do we know the square root of -1 is? Well, according to what we have here, the square root of -1 is going to be I. So then I have square root of 7, I. And there's nothing else I can simplify there. So rest assured, any time you're going to have a square root of a negative number, there's going to be some kind of I in there, as in the following examples. So let's try question B. The square root of -16 equals to the square root of 16 times the square root of -1. Because again, square root of 16 times square root of -1 is square root of -16. With this said, we know the square root of 16. What's the square root of 16? It is 4. What's the square root of -1? Is I. So therefore, my answer is 4i. Okay. And then we also want maybe the square root of c, or negative square root of -13 equals to, and I might leave that for the end. I want to kind of jump to, I'm going to write the other ones, but I want to jump to e, which e says the square root of -48. So at e, I still want to factor out, right? But I'm going to kind of look at, I'm going to factor it in this way. I know there's a 16 in here. And you might think, okay, well, why is 16 this time? So, but what I'll tell you, square root of 16 times square root of 3, that's 48, times the square root of -1. If I multiply all these together, I get the square root of -48. But a couple of things I know. I know the square root of 16, that's 4. I don't know the square root of 3, and I know what the square root of -1 is. The square root of -1 is I. So I would just put I there. And so there's my solution. From there, I'd like you to try C and D. So try to pause the video, work on that, and I'll show you up here. Okay, so to do these, you're going to take the negative remains, I'm going to write square root of 13, write square root of -1. But from there, what happens to the square root of -1? We know that is I. So my answer is -13 I. Negative square root of 13i. Okay. Kind of a similar thing here. You just got to be careful with the negatives because this negative remains on the outside. So square root of 64 times the square root of I. We know the square root of 64 is 8. Oh, -1. -1. Square root of 64 times the square root of -1. Square root of 64 is 8. Square root of -1 is I. So that's how you'd answer those first set of questions. Okay, so now to move on to when we combine a complex or a real part and imaginary part, in the way it says on your notes, you end up with what we call a complex number. Where A we call the real number, and B we call the imaginary part. So there's two parts. There's the imaginary part and then the real part to a complex number. Okay, with a couple of stipulations. A cannot be 0, which is noted on your work, and B cannot be 0 as well. So in order for this to be an imaginary number, you have to have both parts. We also have this other term called a pure imaginary number, which would mean something like just BI, some number times I. Okay, but for the most part, this is what we call complex numbers. Okay. But it all goes back to I, which we know now is the square root of -1. Okay. Okay, so now that we talked about complex numbers, we're going to talk about how you can add and subtract complex numbers, which really has a lot to do with kind of what you've done before, kind of like combining like terms. It's not really too much different than that. But let's look at some examples. So you have an example there under the addition and subtraction. One of them says a plus 6i plus 3 plus 2i. Okay. With this said, all you really need to do is, like I said, you're going to add the real parts, which those are the like terms, and you're going to add the imaginary parts. So in this case, the real parts are 8 plus 3. It's going to give me 11. And the imaginary parts is going to be 6i plus 2i, which 6i plus 2i is going to give me 8i. And that's my solution. Okay, so the addition is not that bad, and neither is the subtraction, but there's one thing on the subtraction that I see commonly as a mistake that students make, and that mistake is with the minus here. You don't want to just subtract 6, okay? In fact, I would take an extra step here to make this a lot easier for you and to make sure you don't make mistakes. You need to distribute this negative. So this becomes -6 and that becomes positive 3i. What a lot of students end up doing is they just end up minusing 6 and not changing the 3i. And then of course you're just going to bring this down. Okay. From there, now it's pretty much like the addition one. You're just going to combine like terms. So 4 minus 6, that's going to give us -2. 5i plus 3i, that's going to give us 8i. So there's my complex number when I subtract those two numbers. So that's addition. Let's move on to multiplication. In multiplication, you're going to kind of do a similar thing to what we did earlier, but we want to combine these. So I'm gonna start with square root of negative 16 times the square root of negative 25. Well, what we should see is that you can kind of do what we did earlier, which is square root of 16 times I, or times the square root of negative 1. And I guess we can jump to that if you wanted to. What I just did, if you see it, then anytime you see a negative in there, you can probably start to see that that's just going to end up being I. But I'm just going to show the work for now. Now, what else do we know about this? Well, we know the square root of 16. The square root of 16 is 4. We know the square root of negative 1. What do we say that was? That's I. We know the square root of 25. That's 5. And we know the square root of negative 1 again is I. Okay? So now 4 times 5 we know is 20. And I times I is I squared. Right? But if we think about what we said earlier, what's I squared? Well, it's square root of negative 1 times the square root of negative 1. Or in other words, the square root of negative 1 squared. The square root will cancel out with the square, therefore, anytime you see I squared, you should know that you can just replace it with negative 1. Okay? Which means this is going to be negative 20. Alright. And there's a lot of steps that you can skip in here. I just like to show everything just to make sure you understand what's going on. For instance, you could probably go straight from here. I know the square root of 16 is 4. I know it's a negative, so I know there's going to be an I. I also know the square root of 25 is 5. And I know it's negative, so there's going to be another I. And then I probably wouldn't skip too many steps in here just because it's easy to mess up with some of the negatives and things like that. But that's A. B would be multiplying a binomial by another binomial. So let's look at that real quick. So here we have 1 plus 2i multiplied by 1 plus 3i. Okay? So it's not much different than what you've done as far as distributing, or some of y'all like to call it FOIL. But I do this. We're just going to get this one, multiply it by these two. Right? Just like we do when we distribute. 1 times 1, that's 1. 1 times 3i, that's 3i. And I'm going to get 2i and multiply it times these two. 2i times 1, that's 2i. 2i times 3i, that's going to be 6i squared. Okay? But what did I say? Anytime you see an I squared, what is I squared? That's right, it's negative 1. So 1 plus 3i plus 2i, that's 5i. 6 times I squared, we know is negative 1. Anytime you see I squared, substitute negative 1, because that's what it is. From there, I can go a little bit further. I'll get 1 plus 5i minus 6, which is 1 minus 6 is negative 5 plus 5i. And that's my final answer. Yeah, I have it in a complex number form. So that's how you do that question. So take some time to try C. Just remember that on C, 3 minus 7i squared is really, a squared is what? It's when you multiply a number times itself. So 3 minus 7i squared is actually 3 minus 7i times 3 minus 7i. So start there. It'll end up being like this. So pause the video, try that out. So, like I said, 3 minus 7i squared, you're actually going to do 3 minus 7i times 3 minus 7i. Okay? From there, you'll do kind of a similar thing that we did on B. Just distribute 3 times both of these. 3 times 3, that's 9. 3 times negative 7, that's going to be negative 21. I, and then you're going to do 7i, negative 7i times 3, which is negative 21i as well. And then negative 7 times negative 7 is going to be positive 49i squared. But what do we say I squared was? I squared is going to be, if I combine these, that's negative 42i plus 49 times I squared is negative 1. So anytime you see I squared, you know it's going to be negative 1. Again, because the square root of a negative 1 squared the square root and the square will cancel out. So now I have, I'm gonna kind of jump a step here, but I have 9. This is going to be negative 49. So 9 plus negative 49, that's going to be negative 40. Minus 42i. And that would be my final answer there. Okay. So that's how you multiply different complex numbers. Okay. But let's talk a little bit more about I. So I told you about I, and then if you square that, you're going to get I squared, right? But let's look at something. So I, we said, was the square root of negative 1. And if we square that, we also said that you will get negative 1. But what happens if I multiply I squared times another I? So I squared times another I. Then I end up with I to the third, right? And maybe I want to write it this way, actually. I'll put I to the third here, which I know is I squared times another I. But guess what? I know what I squared is. I squared is negative 1 times another I is times I. Negative 1 times I is negative I. Okay? From there, I know I to the third is actually negative I. But let's go a step further. What about I to the fourth? Okay, well, I to the fourth is really just I to the third times an extra I, right? That's I to the fourth. But I already know I to the third. I to the third is negative I times I. Well, that's negative I squared. But what do we say? I squared is always negative 1, right? So I'm going to have to squeeze it in here, but I squared is negative 1, so negative negative 1, which equals to positive 1. Okay? They got a little messy there, but I'm going to keep going with this. We have I to the fifth. Well, what do I know I to the fifth is? I to the fifth is just I to the fourth times an extra I. But I already know what I to the fourth is. I to the fourth is 1. So 1 times an extra I is 1i, which is just I. Okay? And a little bit more, so maybe you see the pattern, but I to the 6, well, what is that? That's going to be I to the 5th times an extra I. Right? Because I to the 5th times I is I to the 6. But I already know what I to the 5th is. I to the 5th is I times an extra I. That's I squared, which we said I squared is negative 1. Right? Let's keep going, but we're gonna see a pattern, hopefully. So now we have I to the 6. We know I to the 6 is negative 1 times an extra I. We get I. So it's negative 1i, or in other words, negative I. And then final one that I want to do is I to the 8th. I to the 8th is I to the 7th times an extra I. Well, I to the 7th I already know is negative I times an extra I. That's negative I squared, which is going to be negative 1, which equals to positive 1. So why do I show you all this? Well, what do you notice about the first one and the fifth one? Right? They're both I. What about the second one and the sixth one? Well, they're both negative 1. The third one, I to the third and I to the 7th. Well, they're both negative I. I to the 4th and I to the 8th. Well, they're both 1. So what does that tell you? Every fourth one is actually going to be equivalent, right? So now you could answer questions like A, which A says, I to the 37th. Find out what I to the 37th is. Now, you probably don't want to do this 37 times. I don't think. You probably want to go to sleep at some point. But what you could do is maybe figure out up to what factor of 4 fits in there, right? And if I can figure that out, then I can figure out maybe what the remainder is, and then I can see which one of these 4 it's going to be. It has to be one of those 4. So one way we can think about doing it is, I know every fourth one is going to be 1. So that could help me. right? Because I know I to the 8th is 1, so that means I to the 12th is 1. That means I to the 16th is 1. I to the 20th, 24th, 28th, 32nd, and 36th. So I know I to the 36, that's actually 1. Times, I need to make this I to the 37 times an extra I. So in fact, that's 1 times I. And that's my answer. It's just I. Okay. Another way I've taught this was, this is actually a good spot where that old school long division with remainders actually is useful. So you could do 37 divided by 4, right? Which 37 goes into 4. It's going to go in about 9 times. So 9 times 4, that's 36. Subtract, you got remainder 1. Okay? So that means that this is going to be remainder, this first one will be remainder 0 here, and I'm going to do it in a different color just so you can see it. That's if you get a remainder 0. That would be if you get a remainder 1. That would be if you get a remainder 2. And that's if you get a remainder of 3. Okay? So in this case, we got a remainder of 1. So what was the answer? Would end up being I, right? Oh, okay. Hold on. Let me mix that up a second. It should be 1, 2, 3, 0. 1, 2, 3, 0. Okay. So now it works. Is what I'm telling you. Okay. So it's remainder 1. The answer was I. That answer was I. So both ways work. Okay. And I'll kind of verify both ways with kind of the following. Okay. So B. B says, let's find out what I to 58 is. Okay. So I already kind of told you use factors of 4. So maybe we'll try it. We'll see how many 4s can go into that. If 10, that's 40. If we try 12, that would be 48. 13 is 52. 14 would be 56. So it seems like it would be going 14 times. So in this case, I can just write out of the 56, because 56 is a factor of 4, times how many left over out of the 2. Because 4 goes into that, I know that any multiple of 4, any power multiple of 4 will be 1. So that's 1. Times I squared, well, I already know what I squared is, right? What's I squared? It's negative 1. So 1 times negative 1 is negative 1. Okay? But again, can you do it the other way? Well, sure. You're just going to do 58 divided by 4. 58 divided by 4. Okay, that'll go in once to 5 here. You subtract, bring down the 18. 4 goes into that 4 times. 4 times 4, that's 16. So you have a remainder of 2. You go over here. This is where you would apply your remainders. Since it's a remainder of 2, I know the answer is going to be negative 1. So either way works. All right. So what I would want you to do is go ahead and try C and D. Okay, try C and D. Pause the video. Try C and D. All right. So on C, you would go out of the 75th power. We'll see how many times 4 goes into that. So 4 times 21 would give me, or 4 times 22 would be too high. 4 times 20 would be too high. 4 times 18 give me 72. Right, 36, 72, yep. So 72 would be the closest it seemed, times I to the 3rd, right? Since this is a factor of 4, right? Every 4th one is always going to give me 1. I already know I to the 72, that's 1. Times I to the 3rd, well, what's I to the 3rd? I to the 3rd is negative I. right? According to what I did earlier. 1 times negative I is just negative I. Okay, so that's a method. I kind of feel like more of y'all would want to lean on the other method I showed, which is the division, right? The use of this. 75 divided by 4. 4 goes into 7 once. 1 times 4. Subtract, you get 3. Bring down the 5. Okay, 4 goes into that 8 times. 8 times 4 is 32. Subtract, you get a remainder of 3. You get a remainder of 3. Go down to how I numbered the remainders there. You get negative I. Same thing. Okay. Excuse me. Either way works. Either way works. So D is not too bad because D is a multiple of what? It's a multiple of 4, right? So if it's a multiple of 4, every fourth one is going to give you 1. So that's my answer. And you could have did it the other way too. 80 divided by 4, we know that's 20. No remainder. Remainder 0. So remainder 0 would be 1. So that's how you can kind of work on problems like those. But let's move on to the next section, which is conjugates. Okay, so conjugates are numbers that appear if you have one with an a plus an imaginary number, its conjugate is a minus bi, or also the alternate way around. You could say a minus bi has a conjugate of a plus bi. So in other words, the imaginary numbers are opposites. If one's positive, the other's negative. Okay, so that's how you would express a conjugate. So with this said, the example says find the conjugate of the well, it says the conjugate. Find the conjugate and multiply. That's what it should say. So the first one on our example is negative 3 plus 7i. Okay, so that's kind of in this format. I'm going to go ahead and set it up as if I were going to multiply it, but what's the conjugate of that? Well, you just change the imaginary part. So it's positive, we're going to change it to negative. That's the conjugate. Okay? And we've actually done this too today. So we're just going to distribute negative 3 times negative 3. You get 9. Negative 3 times negative 7, that's positive 21i. 7i times negative 3, that's negative 21i. And negative 7 times negative, or positive 7 times negative 7, that's negative 49i squared. Okay? And then what do you notice is going to happen, which actually always happens with conjugates, is that the middle terms will cancel out. Okay? So in this case, at least with conjugates of imaginary numbers, or complex numbers, I'm going to end up with those canceling out. But I also have 49 times, well, what do we say I squared is, right? It's come up a lot, so it'd be good to memorize that. It's negative 1. So anytime you see that I squared, you just got to make sure you put that in. This becomes 9 plus 49 because the negative times a negative, and then 9 plus 49 is 58. So that would be my answer for that one. Okay, so why don't you pause the video, try to find the conjugate of the following two questions. So 14 minus 5i, what's the conjugate of this? Well, again, you're just going to change the imaginary part. It's minus right here, so I'm going to change the imaginary part to plus. Okay, and then from there, just kind of like the work we did earlier, we're going to distribute. 14 times 14 is 196. 14 times 5, that's 70i. Negative 5 times 14, that's negative 70i. Again, those will cancel. Negative 5 times 5, that's negative 25i squared. So I end up with 196 minus 25 times, that's right, negative 1. Which that ends up being plus, and then this would end up being 121, or 221. And so that would be my final answer there. So you might have got tripped up a little bit on the final example, because the final example only has one term, right? But again, that's okay, because the conjugate of that, you just need to find the opposite of the imaginary part. Well, there's only an imaginary part. So to multiply 8i times its conjugate, I would have to multiply by negative 8i, which we did this in the first examples we talked about. 8 times negative 8, negative 64. I times I, that's I squared. But guess what? I squared is, that's right, negative 1. So negative 64 times negative 1, that's positive 64. So that's how you multiply 8i and its conjugate. And then there's also more on this, but it's kind of the same. In fact, 5. In fact, B is the same, so we're not going to do B again. Yeah, but let's try that other one just for more practice. Then we'll kind of get into ones that I think you'll need a little bit more help with. In fact, I might actually add some. So here, let's just kind of work on it. 5 times 5 is 25. 5 times negative 7i is negative 35i. And then we're going to do 7i times both of these. 7i times 5, that's positive 35i. 7i times negative 7i, that's negative 49i squared. What happens in the middle here? That's right, it will cancel. So I get 25, those cancel, minus 49 times negative 1. 25 plus 49, that's going to give me 74. And that would be my answer there. And like I said, B is kind of, we did B on the example above, right here, or to the left. So we're not going to do that. In fact, I might use the space for B to give you an additional division one, because I don't think that's enough examples there for you for the division. We'll do an extra one, okay? Just one for today. And then we'll be done. So here on the divide, it says divide 2 minus 5i divided by 1 minus 6i. Okay, so write it like this. I think people forget that fractions, that's the symbol for division. Okay, so we actually want to divide 2 minus 5i by 1 minus 6i. So how do I go about doing this? Because we don't really like i's, kind of like square roots. Math people and math textbooks, you won't see a square root on the bottom. Okay, so how do I get or i's? You don't want i's on the bottom. How do I get rid of square roots and i's? Well, it's actually the same tactic. In fact, we saw it here. How do I get rid of an I? You multiply something by its conjugate. Then you end up with the real number. Okay, so that's exactly what we're going to do here. But we can't just multiply the bottom times its conjugate, which its conjugate is going to be plus, right? I have to actually do top and bottom, because if I just do the bottom, then that's not going to be the same equation as it was before. So in fact, if I multiply by this, what's any number divided by itself? That's 1. That's why you can do that, right? You're not changing this, you're just changing the way it looks. So now let's just go ahead and carry out the work. On the top, you're going to do 2 times 1 and 2 times 6i. So that would be 2 plus 12i. And then here you're going to do negative 5 times 1 and negative 5 times 6i. So that'll be negative 5i minus 30i squared. We'll simplify that. Okay, and I'm going to change the color up for the bottom. But the bottom you're going to do the same, right? So you're going to do 1 times 1 and 1 times 6i. So then 1 times 1, that's going to be 1. And then 1 times 6i, that's going to be 6i. And then I'm going to do negative 6i times 1 and negative 6i times 6i. So that's negative 6i. And then that's going to be negative 36 I times I, that's I squared. Okay? So a couple of things we should notice in the bottom. One, those are going to cancel, right? And then two, that's going to be a -1, and also that's going to be a -1. So let's make the changes, and then I can also on top, if that's going to be -1, maybe I'll make a leap here. That's -1 times negative, that's positive 30. 30 plus 2 is 32. Just to write a little less. 12i minus 5i, that's 7i. Okay. We already said that those canceled, but again, kind of similar situations on top. I squared is -1. -1 times -36, that's positive 36. Positive 36 plus 1, that's 37. Excuse me. If you need to work the intermediate steps, kind of think about what happened there. But what we end up with here is a fraction with a number that is not an I on the denominator, which is exactly what we wanted. Okay, so let's try one more, because I don't think one question does that justice. Let me give you an extra one, and then that'll be it for now. So here's another example. You can do it on that space above where we skipped B. So let's try to divide 3 plus 5i divided by 2 plus 7i. Okay, so we're going to try to do this. In fact, why don't you try it, then I'll work it out. I'll show you exactly how to do it. Okay, so what are we going to start with? We're going to multiply by the conjugate, because we don't want i's in the bottom, so we're going to multiply by the conjugate of 2 plus 7i, which is 2 minus 7i. But we have to do that on top and on the bottom, because again, we're not trying to change this, we're just trying to change the way it looks. So from here, I can start my distribution. 3 times 2, 3 times -7i. 3 times 2 is 6. 3 times -7i, that's going to give me -21i. And then I'm going to do 5 times 2, 5 times -7i. 5i times 2, that's positive 10i. 5i times -7i, that's -35i squared, over, and then I'm going to distribute the bottom as well. And notice I didn't put parentheses here. You don't have to, because the actual fraction itself is a grouping symbol. But 2 times 2, 2 times -7i, that's 4. 2 times -7i, that's -14i. And then 7i times 2 and 7i times -7i. So 7i, that's positive 14i. All right, those cancel. And then you're going to get -49i squared. Okay. So these will cancel, and then maybe we'll skip a few steps, but here in the middle on that part, I can say that's going to be -11i, but let's start here. 6 minus 35 times -1. -35 times -1, that's positive 35. Positive 35 plus 6, that's 41. And then I'm going to combine these two. -21i plus 10i, that's -11i, over 4 minus 49 times I squared. Well, I squared is -1. So -1 times -49, that's going to be actually positive 49, plus 4, which is going to be 53. And that's how I know I'm done. There's no i's in the bottom, which is exactly what I wanted. So make sure you go on my math lab, get the homework turned in for this section and the previous section that we covered last week. We were kind of ahead of schedule, fortunately, on that one. But hopefully that was helpful. Good luck. I will see y'all next week. Take care.